So today I'm going to go through kind of learning to explore, unfortunately through boring ass code rather than, exciting temples or jungles or anything like that, but never mind. So the most widely accepted definition of modern agile testing is that it's the art of gathering and presenting as much information about all areas of your application, process, and business as quickly and as regularly as possible, right? So I'm, I guess, going to tell you why exploratory testing is a great means of achieving this. I'm going to tell you how to do it really well. I'm going to tell you how to sell it as a necessary part of your test strategy. And I'm also going to do a bit of myth busting around the problems that generally people try and tell you exist with it and prevent you from doing it. So as I said, yeah, I'm going to talk quite a lot about testing, but I do kind of hope that everyone can learn a little bit from this, if not a lot. If I can find my mouse, there we go, let's get into it. So traditional manual testing, I mean, it's predictive, it's prescriptive, and it's predicated on everything working according to requirements, right? It exists as a mean to optimize for MTBF, for mean time between failures, which is essentially how long can you go before your application blows up. It comes from a time when testing meant getting lots of people together in a room who are employed to step through scripts one by one. Now, that's not testing in my book, that's checking. And when asked to perform the same repetitive tasks over and over, humans are prone to error. But you know what isn't? Robots. So we should be employing automation to check this stuff, provided that automation is valuable, right? And we should stop using our human testers as safety nets, because frankly, it's inhumane. So let's look instead at what exploratory testing can give us on the right there. So when employed alongside automation, it can guide our future development. It can provide us an understanding of the application that we currently have, like its current state, but it also uncovers models of customer and application behavior, and it provides us serendipity of mind, knowing that what we have is what we think we have. If you need more convincing, then good testers, in my opinion, should be obsessed with quality and efficiency. Exploratory testing is the concurrent design, documentation, and execution of tests or potential test scenarios. That's 3 birds and 1 stone. That's an absolute dream for a group of people obsessed with efficiency in my book. Studying what you actually have so far and thinking, should it do this, rather than having that expectation of it should do this, invites open conversations on the quality of your product from multiple perspectives. You can have those conversations with developers, with testers, with users, with stakeholders, etc. And lastly, it's a really cognitive task. We've talked about cognitive load a lot today already, but so I guess what do I mean by cognitive in this respect specifically? Well, it employs all of these things and probably more that I haven't listed. So modeling, like the ability to imagine and visualize the product and its inner workings, critical thinking, the scientific method of constructing theories and challenging them, social knowledge, so it's not just code. This stuff that we're building exists to achieve a thing for human beings, so it has to work in that context as well. Excuse me. Risk mitigation, so understanding what a problem could be or a future problem could be and preventing that. Cognitive psychology, the process of understanding your own and other people's thought processes and patterns and how they can be fooled, and kind of knowledge of bias and all that stuff. And then kind of the metacognition side of it, understanding your own understanding of that and trying to improve yourself by improving the understanding of that, kind of spectating yourself to make sure that what you're doing is always the best that you can be doing. A little bit of logic is involved as well, because after you discover a potential problem, you have to derive conclusions from clues that you've discovered through various forms of reasoning. Epistemology, the art of explaining yourself, because once you find the problem, you have to explain to other people why it's so important that it is a problem and that it gets resolved at some point, and how sure you are that your statement is true, and how you kind of prove that your statement is true. And then obviously a little bit of creativity as well, just in designing the tests themselves. So yeah, plenty to think about when you are exploring. So that's kind of what it is and what it entails. So how do you do it well? Well, the first thing you have to do in order to be able to valuably provide feedback on a system or an application that you're to be testing, the first thing you need to do is learn about the system, right? So traditionally, this was done by reading through design documents and functional specifications and old test cases and, large documents that define how something is expected to work according to the author's expectations, documents that very quickly get out of sync and out of date, and they never get updated once they're first written. So nuts to that, basically. I mean, behavior-driven testing is important, sure, of course. We want our app to be doing what we expect, but what have I said about having expectations? If you can unambiguously state what you think your application should be doing, then you can automate the test for it, as has been mentioned in previous talks. So we're going to learn about the application that we currently have by using it. Simple. And while we're at it, we're going to capture our newfound understandings for later use in designing some automation, maybe, or just repeating the tests that we've done before. So how do we go about learning the application then? When you first kind of get introduced to Exploratory, it's nice to have a bit of a backbone. And I find these kind of concepts are incredibly simple, but they are really, really good for training your brain at thinking in a certain way, essentially. So you need to start thinking about your software in terms of nouns and verbs, where a noun in this context is anything that the software can manipulate or that it manages or that it otherwise interacts with. And a verb is an action that you can take while using it or that the system itself can take. You start noting down all of these little things that your system has and can do, and you start using these words and only these words when you discuss your software. And I can guarantee you that you'll find at least one instance of misunderstanding through miscommunication or a disagreement on terms, like right from the off, before you've even touched a keyboard. So that's, already exploring your process. While you're hunting down these nouns and verbs, start kind of considering your software where it can potentially branch off or achieve the same thing in multiple ways. So as an example, some of you guys had problems earlier logging into the Lean Coffee thing because you were trying to log in through Google or through Facebook, but if you just made a new account and logged in through that, it worked perfectly fine. 3 different ways of achieving the same outcome, 2 of which didn't work, 1 of which did. They are a regular culprit for it works here but not there, and it reveals that what we have right now isn't what we thought we had. Another useful thing, context diagrams. Software lives within an entire messy ecosystem. It sits in a box which communicates with other boxes through gateway boxes and sends huge amounts of data to other massive boxes that are stored in even bigger containers, all of which contain tons of minutiae to configure correctly. So just start drawing really simple little box-to-box diagrams of your ecosystem as you currently understand it. Keep that diagram visible somewhere that is like within easy reach, and as you start learning more and more about the system, you can add to that little context diagram and you end up with a big old map of your personal understanding of this thing that you can take to people and go, look, this is what I know so far, which is invaluable when it comes to having these conversations. And then every system that you find also provides additional opportunity for exploration, so win-win. So I've mentioned variables here. I'm not talking variables in the info sense. I'm talking about literally anything that can vary. So there's, obvious stuff like drop-down boxes and things that appear in that. There's a little bit of not so obvious stuff like get query parameters that exist in the URL, but you have to go hunting for them. And then there's really subtle things like things that can only be controlled indirectly, like the concurrency of users in a system at any particular point, or the number of results returned by a particular search parameter. these are the kind of things that are pretty much impossible to account for during development. As a kind of side note, if you fancy doing some research into an old piece of machinery called Therac 25, so it was designed to essentially give patients automated doses of radiotherapy based on some number of inputs, and it was involved in at least 6 fatal accidents between 1985 and 1987, all of which were down to they thought they'd tested it to a good degree. They essentially got their 100% test coverage, but they didn't actually use it at all before they put it to trial. So some of the problems that it had, there was arithmetic overflow from using an incrementing flag variable. There were problems with non-standard key sequences, which basically meant if you chose one option and then backed out and then chose another option, the machine would just perform both options. There were race conditions between the hardware and the software, so like sometimes the radiation dose was given before you actually put in the number of doses that it needed to give and stuff like that. It was just a real mess, basically. Absolutely terrifying that lives were lost because of the software malfunctions, basically. Yeah. So the last one in the middle, language, kind of encompasses all of this. You know, as you capture everything, just be mindful of the fact that you are writing a ubiquitous domain application language that describes your software. And that kind of comes in handy, as I said before, when it comes to having these discussions, making sure that everyone's on the same page. I think it was also mentioned earlier just how important language is. Making sure that everyone shares an understanding is something that's incredibly difficult to come by. Okay, so that's how I would personally suggest learning how to learn your software. So now we have an understanding of our application, and we know how to kind of explore it meaningfully. Let's get down to actually doing it, right? So traditionally, we would, you know, script-based testing, documentation-centric. We'd write plans and strategies and test cases and procedures, and no thanks. What we're going to do instead is write exploratory test charters, and they will document our exploration as we go. And we're going to run them in sessions using heuristics to help us think about our situation that we're currently in, and any potential kind of risks around us and that sort of stuff. So what is a charter? So as I said, we want to write less documentation. We don't want to write no documentation, one of the classic misunderstandings of Agile. So we write charters, simple statements of intent and of the information that we hope to discover through our exploration, right? So these are basically our focus. They can be as broad as you want. They can be as narrow as you want. You can do things like, I don't know, a charter for a particular user persona. You can try and break things as part of your charter if you want, or you can literally just say, I'm going to explore the system. It doesn't really matter, just as long as you have a focus area. So this is my template for charters. Feel free to steal it or create your own. I don't mind, as long as you are exploring, you're good in my books. So in terms of what I would do, I typically give it a title that I can flick back to and remind myself of exactly what it is that I'm trying to achieve here. Describe the areas that I'm interested in viewing. What time did I start, in case I want to come back to it at a later date, or so that I can compare when I did this test to how many times the system has changed since. And then lastly, who is involved. Quite often important if either you have multiple testers testing the same area, or if you want to get like eyes from a different department involved. So you might want to involve like developers or people from the marketing team or that kind of thing. Just helpful to kind of remind yourself of who you were with when you went through this. And then these lovely quadrants. So I typically use these just to kind of arrange my thoughts, essentially. So a problem is something that makes me think, this definitely shouldn't do this. A question is something that makes me think, should it do this? An idea is something that makes me think it would be better if it did this. And then praise is obviously stuff that makes me think it's amazing that it does this. And then at the bottom, just a really shorthand write-up of the kind of things that I did specifically over the hour or hour and a half, or however long I've kind of assigned myself. And then at the very bottom, potential new charters, things that I spotted while I was exploring that aren't within my current focus area, but that I definitely want to come back to at a later date. Really simple stuff, but it's just a really nice way of kind of organizing your thoughts on paper. So I mentioned heuristics. This slide is supposed to be overwhelming because there are hundreds, if not thousands, so many different ways that you can think about things while you're going through your software or your application under test. So these kind of aim to I guess, simplify the methods of cognitively testing your application, but at the end of the day, you are still going to have to use your brain power. That's why it's kind of important to time box, because you can only think hard for so long, cognitive load and all that. I've got a link to where I kind of took most of these from at the end of the slides, which I'll give you. Some of them I've made up myself. I'm more than happy to come back to this at the end if anyone has any questions on any specific ones, but I'm just going to go ahead now. So sessions, yeah. So when you've designed your charter, you want to plonk it somewhere that everyone can see it, so that you know that it is a tangible piece of effort that is going to have to be spent at some point in the future. So that's, I don't know, Jira, Trello, GitLab, sticky notes, whatever you use to kind of track work that you're doing. Essentially treat it as you would any other development task, really. When it comes to actually running a session, you pick up your charter, you kickstart it. You just want to time box it, obviously. You want to keep your notes, your diagrams, your heuristics cheat sheet nearby. During a session, if you notice you're going off on a tangent, try and use the charter to keep yourself focused and on track. You want to kind of take note of the shiny, distracting thing that you want to prod around at, but make a point of staying on your current track for now. When you're done, write up all your notes. As I said, these kind of shinies, these bits, these forbidden fruit, as it were, those things make great new charters for you to carry on exploring different areas. It's important to find time to socialize your findings as well with the rest of your team. And that way we can kind of start to get exploratory testing considered as part of the day-to-day activities of a tester and a general development team, or Scrum team, as it were, sorry. Yeah, so in my experience, kind of making the value that a tester brings to the team tangible and visible is incredibly important, and in personal experience also can be quite difficult at times. And I guess another thing to call out is just to remember that the sort of testing you would usually be asked to do for every story in a sprint, that sort of binary, does this work, yes or no, that's checking, not testing, and should be automated after very careful consideration of the worth of that check. So I said I'd do a bit of myth busting as well. There's already so much to do. Figuring out how to fit exploratory testing in around everything else that we do already. Sprint planning, code reviewing, story writing, fixing and running automated checks, checking every single story achieved by every dev on your team. Our day-to-day is generally quite packed. And it's even more difficult to carve out time for this sort of stuff when there's that kind of classic misunderstanding of exploratory testing, that it's just you slap a keyboard with your shoe and see what happens. That's a genuine theory. It's on the internet. I can't remember who did it. I think it might be Michael Back. Anyway, sorry. So that kind of myth, it gives your Scrum lead or your project manager little to no faith that exploratory testing is a worthwhile task, considering there's already so much to do. And what I would kind of say to this way of thinking is, does every individual story actually need testing? If we know its intended outcome. Like we know the behavior that we expect this job to achieve. Tests should already exist for it, and also should exist for its tangentially related areas to ensure that you haven't broken anything. You know, we have CI/CD, we have a strong automation strategy, framework, process, whatever you want to call it. It's better for us to go quickly, to learn quickly, and to shorten those feedback loops, and to not be afraid to fail, to remove that testing safety net, as it were. So I guess just as a side note, I've mentioned automation quite a lot through this talk. Luckily, there was a brilliant talk before me about automation, but I guess I would just like to clarify, automation doesn't mean running scenarios through your UI into an opaque box of services and confirming that what happens on the front end is what you expect, right? When I talk about automation, I mean everything you do that uses technology to assist with your testing or your development on a day-to-day basis. So that can be unit testing, integration testing, API and functional, contracts, snapshots, headless browser driven against stubs, you know, data-driven checks, accessibility, performance, security. You know, there's a wealth of automation levels out there that exist to help you consistently gather feedback that the application is doing what you expect. And all of those kind of things are talks in and of themselves. But I guess what I'm trying to say here is that if you optimize for MTTR rather than MTBF, so that's mean time to recovery, so the ability to bounce back from a failure rather than trying to prevent a failure from ever happening, which we all know is fundamentally impossible. So we try to mitigate failures by rectifying them quickly, not by trying to ensure that they never happen. We'll be on the path to efficiency and quality in no time. If you don't believe me, then you can go and check the state of development or the state of testing or the state of DevOps reports that I think it's Google releases every year. The past few years has been a rising trend in the top performing companies, always optimizing for MTTR. So I guess I'm not saying that we kind of purposely deploy potential problems into production. I'm just saying rely on CI/CD more to catch critical path errors before they even make it that far. Use exploration to guide future development and to learn as much as possible about what we have right now. Leave the checking to robots. Break those testing misconceptions. Be a testing humanitarian. And let us start doing what we love and are good at. So a quick recap, I guess, yeah, learn your system using the scientific method. You know, form a hypothesis and then either prove it right or prove it wrong. Document your learning to show what you have right now. Write your charters, run them in sessions, make them as visible as possible, and then influence future charters with those learnings. And an even shorter recap: quality is good, efficiency is good, exploratory is good. And that's basically me. These are a few of the inspirations from me. The heuristics cheat sheet at Test Obsessed is that massive page that I mentioned earlier. James Buck and Elizabeth Hendrickson are testing idols. You should very, very much go and look at everything that they write. Although take James Buck with a pinch of salt, because he is quite a Marmite guy in some respects, I've heard. Anyway, yeah, that's enough of my waffling.